Nameplate kilowatts multiplied by annual hours is not verified fan upgrade savings.
The nameplate is a rating, not the actual input at every duty point, and scheduled hours are not always run hours. Savings represent a difference between what would have been used and what was used under consistent conditions.
Start by drawing the electrical measurement boundary.
Decide whether it includes only the fan input, or also the motor, drive, controller, and affected auxiliaries.
Record the meter location and exclude unrelated air handler or process loads. Every baseline and reporting value must use the same boundary, units, power basis, and aggregation method.
Next, make the service comparable. Match delivered airflow, static pressure basis, air density, filter condition, operating hours, control state, outdoor or process load, and system configuration.
If conditions cannot be held equal, define an adjustment before seeing the result. A lower kilowatt reading at lower airflow is not verified efficiency savings. Capture the baseline before the old fan leaves.
Record the asset and configuration, interval input power, airflow, pressure, run hours, set points, filter and damper state, maintenance condition, weather and process variables.
The measurement period must represent the operating range.
After removal, a missing baseline may be impossible to recreate credibly.
This is a current Longwell self-developed EC250 product photograph.
It shows real candidate upgrade hardware, but no photograph can establish installed duty, compatibility, baseline energy, or post-installation savings. Select the product from model-specific performance and application evidence, then measure the complete installed system inside the agreed boundary. Choose measurement and verification rigor according to project risk.
Option A measures key parameters and stipulates others. Option B measures all relevant retrofit isolation parameters.
Option C uses whole facility energy and adjustment models. Option D uses calibrated simulation. The selected method changes the boundary, data burden, cost and uncertainty. Agree on it before installation. For interval data, energy is the sum of input power multiplied by each valid time interval.
Check kilowatts versus watts, hours versus seconds, meter scaling, time zones, clock shifts, duplicates and gaps. Keep the actual load shape.
Multiplying one average power by a schedule can hide starts, stops, part load and overridden control. Adjust the baseline to reporting period conditions. In this illustrative worksheet, measured baseline energy is 16,800 kilowatt-hours. A documented hours and load adjustment adds 900, while an unrelated scope change subtracts 300. The adjusted baseline is 17,400 kilowatt-hours. Every sign, reason, and data source must be visible. Now compare it with 12,900 kilowatt-hours of reporting period energy. 17,400 minus 12,900 equals 4,500 kilowatt-hours. Dividing by the adjusted baseline gives 25.9%. These are transparent demonstration inputs, not a Longwell rating, quotation, or savings guarantee. Do not report more precision than the evidence supports. Meter accuracy, sampling, missing data, model fit and operating variable effects all contribute uncertainty. If the combined illustrative uncertainty is plus or minus 700 kilowatt-hours, state a savings range of 3,800 to 5,200, with the method and confidence basis. Audit the common failures: wrong electrical boundary, unequal airflow or pressure, scheduled instead of measured hours, meter transformer scaling errors, missing intervals, changed filter condition, changed set points, unrelated scope changes, double-counted controls, and no persistence check.
Anyone can turn a precise spreadsheet into an untrustworthy claim.
Release the workbook with scope and boundary, baseline and reporting periods, raw interval data, duty measurements, data cleaning log, adjustment logic, formulas, uncertainty statement, commissioning record, approvals, and version history.
Keep cost and payback in a separate financial model. For an audit-ready fan calculation, begin with duty points, interval power, operating hours, and documented condition changes.